Ho ho ho, and welcome to day 19 here on TryHackMe. This is Adam the Cyber, and we are going to do a room called Memory Forensics today. Okay, so it's crypto minusing volatility. Okay. So I suspect something with crypto minus then. Okay, so let's zoom in a bit here. We're going to talk about what is memory forensics, and basically memory forensics is about analyzing the memory in the RAM, the random access memory, and we use different tools for that. I would suspect we're going to use some sort of weird command line tool for this, but there are really good alternative for tools like FTK Imager, which is probably not the one we're going to use today. Let's see. Okay, so volatile data is something that is stored in the RAM only, and particularly if you are a programmer, you have probably, if you did network programming with threads or processor multi-threading, concurrent programming, concurrency, something like that, well, probably you heard about volatile data. So, a memory dump is a snapshot of a memory that's been captured to perform the memory analysis, which is something we need to do. I suspect we have a capture of the memory right inside here, which is the len.mem. It's a large file. We also have an Ubuntu profile as a zip file. Not sure what that is now, but let's just keep it down. The benefits can be many. We got stuff in the memory, volatile data, which can be used to uncover evidence of unauthorized or malicious actions. Because think about it this way. Whenever you hit the keyboard, whenever you click the mouse, when you do something, you are performing an action, and no action can be executed without it going through the memory, more or less. Right, so everything is going through memory, and in most occasions it is something that can be stored, and if it's stored, it is staying there until either you reboot the computer or you in some way erase it by a new memory. So that is why volatile data is really interesting. There's a small tutorial about the process. A process is basically a program running in your computer, and a process, as it says, independent, self-contained, blah blah blah, which is true. And if you want to continue further on understanding what a thread is, well, a thread is spawned by a process. So if you heard about multi-threaded programs, that's basically a process that spawns more than one thread that can do some task, concurrent in a way, parallel. And they do talk about that a process can be either running as something you see, like a program. It could be a background process, usually something like a driver or something like that. It can also be a background process, like yesterday with the daemon that we shut down. Alright, so connecting to the machine, yada yada, volatile data. We would need to open a terminal because I see we need to do that. We need to access vol.py, which isn't very interesting where that might be. What is this? Okay, so boot stuff. Okay, great. But we need to find this vol.py. I'm not really sure what that is, but anyways. This is set the memory dump, links to device. For your convenience, volatility is already installed. So I'm going to use a program called Volatility, which is a great tool. So can we... vol.py is there for our convenience. So someone created probably a path variable for it, I guess. So somewhere in one of these paths they created, so we can probably try and locate if you would like to know where it is. It is not there. Anyways, let's just go ahead and run vol.py tag h and see that we are having the correct version of 2.6.1, which is true. Alright, so it does say we can run the info to see the different kind of profiles. We can do that. Sure. So let's run the info command. Also, have some questions below. Let me just see what that is. To get the overview of what we're going to do, we are going towards the exposed path, which we find in the bash history output. Okay, so we're doing Linux memory forensics. What is the PIT and the hash? So we're going to use we also need to use cyber chef. Let's just complete the last one. We enjoyed it. So let's go ahead and just basically follow the tutorial and see what's going on. So let's go to the desktop and go into the evidence folder, evidence, and there we have the linux.mem and the ubuntu.zip generic profile. And to use the profile, I have to copy it where volatility stores the various files for Linux. The command is copy this file to that using, and then grab it. We'll take care for us, then run. Okay, so we can go ahead and run this command right there, like boom, and we can do, to confirm it, that command, and it should definitely show us that we have the same kind of output as, let's see, CP, and we have this right there. So we can also go ahead and run this command just to see if that's the same. It was not the command that I copy pasted. Let's do one more time, and we can see that we got the same output one more time, so we should be right on track. Also, we reran the vault.py info grab Ubuntu. We got this part right here, which is exactly what we need to do. So we are on the right track. Okay, guys, so memory analysis. The file linux.mem contains memory dump, yes. The file is located in our home directory. For volatility to begin the analysis, we have to specify the file with this -f, okay, and the profile with tag profile. And since we know it's Linux Ubuntu generic profile 64-bit, that is the one we could go ahead and check out. Did we output the profiles? I think we did not output the profiles, but I think we can just do that if you want to do it. So if you want to see the profiles you have in volatility, just go ahead and use the command, and you can. Wow, it's a long list. Let's see if we can get it. So that's a lot. Yeah, there we have it, right? So we have a lot of windows, Probably somewhere else that we're gonna need. Anyways, let's clear the screen. Let's make this a bit bigger. And now we're doing the actual memory analysis. So we read what we need to do. Let's copy paste the command, put it in, and run it. So now we are calling volatility, giving the file linux.mem, and we are seeing different kind of things going on here. Sorry for that. So we can see different plugin options that we can use. Let's start with the history files. So we then run the command. Linux profile, and then the Linux bash, and then we should be able to do some stuff. So let's clear the screen, run the command, and now that we are running the command, we should be able to get some of the things as an output for the memory file. It can take a while, so less than a minute. So yeah, we're also on a machine, like a virtual machine running on TryHackMe's server, so that's a bit slow. We can see different things going on right here under the Linux bash. I cannot speak today. So we've got sudo su, git clone, some weird stuff going on. And let's make via history. Got the root password right there. I don't know. Do we need to answer some stuff right now? What is the exposed password? Yeah, so definitely go ahead and take the password. What is the PID of the miner process that we find? I don't think we found that so far. Anyway, so we have something called toy miner right there. So they curled it down and saved the output as a miner file. So we have the actual clue right here that we downloaded something. And this is not a part of anything, right? No. So far so good. Let's go back. Because this is kind of exciting in a way, right? Do you like it? So we got the Linux bash, and they do talk about the identified. So what they talk about right here is what I just talked about. So let's go and continue running processes. So then more time we can go and see what was the process running. So one more time, let's copy paste the command, run the command, and I'm gonna wait a bit again. Should take around a minute or so, maybe even less, and this is gonna be so messy. We have something right here down called miner, really lucky for us, and we can probably see that the name, the offset, the name, and the process ID. So that should be the process ID for the next question, because I remember something about the process ID of the miner, and we can just see it right there. So if you go back and see like offset name PID, and you go like miner, like offset name PID, and even though it's a bit distorted on the screen because it's so small, not wide enough, then you can see it. So this is definitely got the process ID. So we got proof of execution, we got proof of evidence, we got evidence that program called miner been running, because we can see that from the prior output that was called miner, right? So we got something here going on. So yeah, we already read that. So now we're going to do process extraction. Let's go ahead and clear the screen, and now we're going to go ahead and say you're going to use that on the file one more time. We can even make the directory. Let's go ahead and do that. So extract it, go and extract it, and then run volatility one more time with the file. The same process every time. This is going to say every time, same thing every time we run it. So I'm going to keep it there. Linux proc dump. So it's going to be process extraction, the extract, and the PID ID. So let's go ahead and copy paste this, and I'm going to take the PID ID from the answers just below. There we go. And press enter. The requested file doesn't exist. Maybe we should go one back, because they did tell that this would be in the extracted folder. I was putting myself in it. Let's go ahead and just run it one more time. You never know what you're gonna get in a box of chocolate, right? So now we're extracting the things, and we should definitely think that we will get something crazy here. So we got the miner, the file, and the extracted output. So we'll go ahead and say ls, going to extract it now. And we can see that we got something right there. We got a file, okay? So let's do an ls tag al. We can see the file is actually off size. So we got something like 5.6 megabyte, which is okay size for program. So we need to answer more questions within the 5 hash. D5. Did we get that? Yeah, so yeah, okay, so they are actually showing us how to do that. We can just do MD5 sum in the miner, or we can take out the hash. So now okay, so the hash itself is not really important to us, as in well, it is important to us. It's important because we can identify that we have a program and we took a hash of it, so we have a checksum of the program, so we can now say that, well, it's there. So if anyone changes it or find it again and it's not the same hash, then we can say that something is different, right? Sorry for that. What is the MD5 hash of the MySQL server process? So now we need to go further on and do some file extraction. So the file extraction is going to be the same one more time, and we're going to grab on cron. So we want to see the cron jobs, which is a clever step. So look at the cron jobs, and the encrypted file does not exist. What did I not do? Oh yeah, we're in the extracted folder. We need to be out of it because we are requesting direct access to links.mem. So remember these kind of things. It should be pretty obvious whenever you are looking at your location in the file system. So we're running the command right now, and I'm not really sure what we're going to look for in this particular case. Let's talk about the MD5 hash of the MySQL process, which is, I guess, somewhere over the rainbow. The 5 hash of the MySQL server process. So we're running the command, takes some time while this is implementation, and while this is being run, we can. Oh yeah, we also we kind of forgot to take the other file. We should also take the process ID of 10,291. And where did I miss that? Why did I miss that? So we can go back. The miner and the SQL file. Yeah, so they also talked about that. So we need to extract the SQL file as well into the extracted folder. Let's go ahead and copy paste the command. One more time. Go to the extracted folder, to the desktop, into the evidence folder, to the extracted folder, and let's copy the command. Oops, one back, and then run the command because we are one step back, and we're going to say into the directory of capitalized D extracted. So we basically just need to run the command md5 sum on this particular. So let's do md5 sum on the extracted, and it's called MySQL server. We're going to get that, copy paste it out, and you see what you miss sometimes. Okay, so we got that, so we know we got it, and we extracted everything now. So now the questions are: use the command with suspicious URL. Yeah, okay, so now that we extracted all this, quickly identify the cron tab in the spool cron tab elfi. Let's see. Did we identify that? Var spool cron tab elfi, which is right there. The whisper elf analysis confirms we didn't have a cron job, so we can do. All right, so we can take the actual address of where it is located and extract that file to elfi. Let's do that. Right there. I hope so. Let's see. Yeah, to the elfi. So the output is elfi. And the I for index. Let's go ahead and check it out. We have elfi right there. And let's check the size of it. It's 233. So let's clear the screen and cat elfi to the screen. And we see inside of here that we got something like, this is the SQL server started. I'm not really sure. Is this the answer for this one here? I think it is. Yeah. So the answer for after reading the elfi file. So we got the MySQL process there, and we use the command strings on the extracted miner. Something. What is suspicious URL? Fully defang the URL using CipherChef. All right. So let's go to the extracted folder one more time. And this is the one we're going to run. So let's do the copy paste the command. we're in the command called strings. Let me just explain that for a while. It is a command that look at the strings that we understand in a file, for example. So that could be you're doing strings on a binary file or just any file, and you're gonna look for something like stuff we can understand, like text or something. So, and we already in extracted, so we can skip the extracted folder, run it one more time, and we see strings from this particular file, stuff like signal using, cannot disable HTTP version, so on and so on. We have a HTTP MAC really secret TMH. I don't know if that is the correct answer. No, it is not. Where was it one more time? Got something crazy going on here. Not really sure what it is we're looking for, but we could probably, let me just see if we can clear the screen, run it one more time. So we got something like with HTTP. Use the command, what's the suspicious URL, fully defang the URL. It does say like it is HTTPS or something like that. It's not HTTP. So it will also be HTTP 2. Very interesting. Let's just, I guess we're going to take all this, go to CipherChef. There you go. And not really sure we're going to look for defang. Was there something URL there? Let's see if we can see anything. Maybe this is not the exact right way of doing it, but let's just try and see what you're gonna get. So we're gonna need some sort of URL. Only full URLs. Maybe we're not doing it correctly. Must admit I'm no big user of CipherChef. HTTP 2, yeah, everything. Okay, so definitely and probably not should take all of it. Alright, so maybe we already have the answer of my greedy service. I don't know what exactly to say, but I think what is defang? Maybe I remember different. But defang is basically just you take the URL. This is the one, MacGreedy. So could probably just take and defang it, I guess. How would that be? Like HTTP, I don't know if that is the correct defang format. No. How would I defang that? I'm pretty sure this is the one. Should be different. Oh, I just accidentally copy pasted that in and press enter and like figured, well, let's just try that, you know. And yeah, so I was just looking at it and thinking what is going on. So basically the defanged one is just using this one right there, and it would work with basically valid domains in full, the process one. copy paste it out, and yeah, that would be it. So it kind of counted this one there as before the dot, which is, I think, this is a weird way of doing it. Anyway, so we got a volatility room going on here. We found some stuff, we completed the room. So yeah, great. Gonna see you tomorrow on day 20, and it's getting soon. Christmas is there already. We feel it. Ho, ho, ho.